Okay. All right. So we are live. Before I totally start, do you want some coffee or cookies? You can get them now. Everything in IT needs coffee, by the way. So you need that. That's a requirement. Okay. I can give you a couple of moments to set up because I see you're still connecting the chargers. All right. Ready. Good. Ah. All right. Hello. So, welcome to the NPR room. I'm glad that you find it. The best room in the whole university, by the way, because it's ours from the KBL. All right. My name is Didier Barradas Bautista. I am part of the KAUST Visualization Core Lab. We are giving these workshops pretty much every year. And these are prerequisites for the other workshops that you're going to probably take, which are the machine learning ones with my colleague Abdul Rafur Halimi, which is here on the center. We have another scientists also in the KBL. For example, Thomas and James, they are wizards with visualization big data on the clusters that we have. And we have Ronald, who is the actual virtual reality expert. All right. So, because we now have a very open web page, you can find it. You can find us there. You can find the trainings that we are doing here. All right. So if you have any question or something, you will also find there probably our contacts. And of course, all right. So you're here because we're going to talk about Conda. Now let's begin this topic with two things. Like let's discuss what's subjective and what is objective, and then how it leads to reproducibility. All right. So for example, if I go to Italy, to a very small place called Napoli, Italy, and I throw this question, who is the best player, the soccer player in the whole history of soccer? These poor souls will tell you that he is Diego Armando Maradona, an Argentinian. He's not even Italian, all right? They're wrong because the best player in all history is Pelé, okay? A Brazilian guy that actually revolutionized it. But that's pretty much an example of what subjective is, right? It's my opinion against others' opinion, even though they might be wrong. But objective is a different thing in science, right? Pretty much here in the university, we all working for being objective. For example, where are you from? You're from China. Okay. If I told you this following equation, force equals mass times acceleration, is that true? The Newtonian force. If force equals mass times acceleration, is that the same in China? You calculate the Newtonian force the same way? You back there, where are you from? You're from India. Okay. Where are you from? Italy. Where are you from? France. All right. So you three are as far as my original country as I can be, because I'm from Mexico. So there's literally an ocean between us. And we all know that it's the same equation describing Newtonian forces, right? And if I give you the numbers, the parameters for mass and acceleration, we all come to the same force, like 10 newtons, 20 newtons, whatever you want. Is that correct? That's objective, right? So that's the power of science in two times. One is objective, is not false. If it's false for everybody around the world. Doesn't matter what you believe, doesn't matter what you think or what you are actually studying. It is just correct. And the other powerful thing is like Newton came with this idea when? Like in the 17th, 18th century, something like that. Very old guy, way back. way, way back into the history of science, right? And that pretty much is why we like science. It's always true, no matter what peak of the time you are actually picking up, right? Now, why we care about this being reproducible, since somebody actually said in Britain after an apple fall from the tree. Why do we care about reproducibility now? Like, for example, let's say in France, do you care about reproducibility on science? Yes. In Italy, in India, in China, everybody says yes. So we care about reproducibility because we might or be wrong, but we want to care about the facts. Now, on computer science, this has been an issue since the inception. Why? Because I have a Mac here. I can see there might be a Windows over there. And maybe somebody here is a unicorn and have Linux. And the three things are different. And because the three things are different, manufacturer-wise, even computing-wise, because the Intel processors are not going to be the same for a Mac or for a Windows machine. Therefore, in the very least, maybe the difference are just causing small changes and they're not so important. But most of the time, in ancient times when I have hair and the dinosaurs were actually roaming the earth, people were saying, like, it works in my computer. So if I do a calculation, I have to literally ship my computer all the way to India so they can run the same calculation and get the same result. So is that practical? I'm going to literally ship, or he's going to ship his computer to me in Mexico just to check out that the numbers are the same every time we run a program? I mean, if you're pretty much rich, you can do that, but I'm not. So I'm not going to send my computer, not even to my neighbor. Okay? So here's exactly why these kind of things enter into play. In computer science, you can ship binaries, you can ship programs. That doesn't always is going to work. Meaning, like, if I make a program, and you probably are too young to remember, the Word that the actual Microsoft Word that is now in the Apple machines didn't work in the Microsoft machines. There were format problems. And it's like, if you are working with the same product, you cannot ship your Word document from a Windows machine to an Apple machine and backward. Ancient problems, I know. You don't have that anymore because you have the cloud and you're young and you're brain with all this technology. Okay, but that persisted even in lower tiers. For example, the Conda environment manager is something that was required to actually start giving people the facility to ship things to another person and reproduce whatever in your computer is happening in another computer, regardless of the manufacturer or regardless of the operating system. So this is exactly why I wrote here, like, this thing in theory, for all purposes of data science and machine learning, should be enough for you to actually write an environment, meaning all the packages that you need to write a program, ship it all the way to the other side of the world. From here, it will be in Mexico, or you can ship it to China, and in theory, they can build the same thing, run your program, and get the same result, regardless that you're using a Mac, you're using Linux, or you're using whatever you have. Okay? That's why the whole arc of talking about reproducibility right now. So what is Conda? Basically, is now a company. It was created pretty recently. It has 12 years. But the gist of it is that it will let you create virtual environments, meaning you don't have to break stuff. So back in my days of gamer, when I was young, I have to try to go to a very dubious websites that were not in my language to try to break the code of how to get into a game. All right? I needed a key. So this is not something that you do now because they are super powerful now. But the thing is, like, you have to install things in your computer, and that can break your computer. If you just install blindly things over and over and over and over, you will break your computer. That's the worst case scenario. Now, if you're working with somebody else in a project, and you have to come to a middle point, it's like, okay, I want to work with you in this project. All right, we're going to use these libraries here to do the calculation that we need, to do the forecasting that we need. But there is something in the middle between you and me, and it doesn't matter what are we using for. Okay? But it does matter what libraries, the version of the libraries, we have the control. And most importantly, because it's virtual, it doesn't break our computers. It doesn't go into the main system of the operating system. All right? That's what Conda is for, as a matter of fact. Okay. So, some perks about Conda. One thing is platform agnostic, meaning you can install it in Windows, you can install it in Linux, and you can install it on Mac. It's all the same for the three of them. It will manage the libraries. That's fine. So you can install a lot of things. People use it mostly for installing things about Python, but it's not just Python. You can use another programming language like Rust. You can install C++. You can install R. You can install your favorite language. That's the thing. You can install Ruby. You can install whatever you need to develop whatever tool you are working on. Okay? So I put on black, avoid dependency hell. This is now, with my experience, partially true. Technically, it's true. What is dependency hell? Remember, I was telling you, I was trying to break into a game. So that means that I start installing libraries and libraries and libraries, and some library has a new version. And that version, it was 3.5, and I was working with the version 3.4. And now both of them have been so divergent that they call different things, and now the whole program doesn't work. So you want to avoid that situation, because now if I want to ship my computer all the way to India or all the way to France, it has to be my computer because it's the only computer in the world that will not break, or something like that. All right, so that's pretty much the idea. But the main objective of this is to make your work reproducible. It's either your workflow or your research. Because we are in a university where research is basically the most important part, this is something that you should take care of, right? So, for example, if I actually ask any of you if your sign is reproducible, everybody should say, yes, of course. I hope that you're not lying to me. But yeah, that's the point, right? Our science has to be reproducible. And if you want to build a tool or whatever to just analyze something, you better make it easy also for the other person to reproduce what you're doing. That's the whole idea of developing tools for these kind of things in computer science and everything that touches. Okay, so we're going to use, as always, I always use this kind of material. The carpenter's material is always there for you, it's online. So if you don't understand my bad English, or I'm going too fast, or you get lost in some part, you have that material, you can go read it. It's going to be pretty much the same. As a matter of fact, I encourage you to do that because I will forget some things. Some tips are there. There is valuable information there. And I will always give you those links in the web page. So talking about the web page, you all see this, right? At least you saw this at some point. So this is the web page I was talking to. You have the workshop materials there. Please go and join the Etherpad right now. Like, the Etherpad is a collaborative document, right? So in that one, you can put your name or not. I put myself as Shifu, because if you want to be a data science, I will be your teacher. Kung Fu Panda? No? All right. too young. Maybe in the next 10 years it will be a good joke. All right, so the material for Conda is right there, here. You can click there. It will send you to the web page of the Conda to the Conda document that you probably want to read. And of course, we have here, just like on the shell, those that you were here for the shell lesson, you find it that there is a class hub, which is a resource here for the university that will deploy the tool that we're going to use. So you click here. I also put the link to GitHub and a link here to access the class hub, because you need a user from GitHub and then update it. We found out this morning this link is broken. So it's not because apparently we're using too much this link. So it will not work as it right now, okay? You can also use the Jupyter Hub. For that one, you have to ask IT. And right now, because you're here, you cannot do it, but you have to ask IT to give you access to different resources. This is one of them. It will also deploy a Jupyter notebook, but I have not tuned that one for this workshop. So that's the only drawback of that one. That's the major drawback, I should say. All right. So for the collaborative notes, please join the Etherpad, like I said. Also, I encourage you to use any of the now digital assistants that we have. We have the Copilot, we have ChatGPT, or we have Gemini. Whatever is your flavor and whatever you want to give your data, go ahead and choose one, just because it will come handy if you have some kind of question. In the last workshop, we used it just to ask for a very, very simple question, but it was useful. At the end of the day, this is what these things are for. Okay? Well, yeah. So for those of you that are here, please, let's start the setup. Just clicking the class hub if you can. Also, I give you the setup, the local setup to do that in the web page. So if you came with the setup already prepared, thank you so much. That was great, because now I can discuss the next slide. So clicking the class hub, or you can go into the binder. If you're in the Etherpad, you will find the binder web link in the top of the binder. Okay, so you can check it out from there. It will take time, so I will keep talking while it's loading. So yeah, for those of you that actually is the first time using the class hub, this might become handy. You have to go into the web's page. It will say Introduction to Binder instead of Introduction to Data Science Workshop. But go all the way down and click on Begin Course. Then it will pop with something, with another web page that says Sign in with GitHub. Click on that one, and it should start deploying something that, like this thing you see over here. Go back one. On this corner, you will see something that is spinning a circle, and ultimately you will have something like this. Okay, for those of you that went to the work of installing the Anaconda Navigator window, you have to check it out, and please start something that is called Jupyter Lab. Okay, not the Jupyter Notebook, the Jupyter Lab. That's for the local setup, all right? That's the trick. Many people goes and try to open a Jupyter Notebook. What I want you to use is the Jupyter Lab, which is a GUI for developing the code that you need. All right. And this is how it should look like, or something like this. Not like, I mean, in the sense that it has to have this kind of a structure. You will see here that you can check all the different documents that you have. And then in the launcher, you have different options like opening a notebook or opening a console. What I want you to do is to go and open a terminal, which is all the way down, and is that dollar sign and underscores, what is it, symbol? Yes, both are symbols. So I will wait for you. If you raise your hand, can you raise your hand once you have something like this? Okay, you already have it, you already have it. Done, over here. Yes. If you install the Anaconda on your computer, you can use your terminal. Okay? Okay, if you have Anaconda installed already on your computer, you can use your terminal. Because this workshop itself, it doesn't need any material from the website. So we're going to work basically in the terminal. Okay? So I'll wait for those of you that didn't raise your hand. You also have it installed. Perfect. Okay, so you can use your terminal. Yeah. Okay, so you have the problem that the link that you need to use is broken. So we're going to redirect you to another stuff. The class hub. Yes. I just sent an email to the administrator to see if he can fix it, because it was not broken yesterday. At least not when I check it. Today something might happen to the hardware. I don't know. But if you have it on your computer, let's work with your terminal on your computer. If not, I do have an option for you. Do you want to hear about that? All right. So if you went to the Etherpad, are you on the Etherpad already? Yeah. It's fine if you want to use. Yeah, you can use it. I mean, the exercise is okay. But for example, yeah, I mean, go ahead and do that if you want. So all good over there? Yes. Right. I will wait for over there. Over there. Okay. In the meantime, if you want, grab some tea, grab some coffee, some cookies. We're not charging for those ones. Okay. All good? Yeah, go ahead. You still have time. Okay, hello. Ready? Nice. Okay. let's wait for a couple of guys that were taking a little bit of coffee. Oh, nice. Okay, now what you will see in the screen or projected over there, those are the things that we're going to revise today. And at my own expense, this is what I think you should all learn, and that's not that difficult. I call it Conda cheat sheet, but there is an actual official Conda cheat sheet if you look for it in the internet with all different Conda and options that it has. So the very first thing that you want to do is create a new environment. That's the whole point, to create a new virtual environment. Then we can use an actual file that will specify what you need, and that's a YAML file. Okay? You want to remove things, and sometimes you want to remove everything, including the environment. And this is one of the things that pretty much you want to do. And those are the three main things that you probably need. From all of that, the other 5 options that I put here, they're pretty much run-of-the-mill commands, because it will tell you how to activate, how to deactivate, how to get the list of things that is inside of your environment if you don't remember, if you want to fetch something specifically from there. So this is pretty much it. Okay, Conda is not that complicated, as a matter of fact, when you just master these commands over here. So, okay, we can start we can start with something like that. In your terminal, check if Conda is already there. If you write in your terminal which Conda, it should tell you like Conda is in some path, blah, 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 and a binary. Okay. Now, if you do Conda dash dash version, you should have different versions of Conda. Okay. But depending on the time you install this. And of course, if you do Conda help, it will deploy all the menus, all the options that you have. So go ahead. So for those of you that just came here, you can check out the Etherpad in the website where you were actually registering. There is the links to the Etherpad. Okay, so raise your hand if you already did this in your terminal. Which Conda dash version, and Conda help? Fast, I like that. Good. All right, this is the first exercise. Doesn't recognize which one? Really? Interesting. Okay. Let me check then. So, all right. Again. Hello. So I'm back into the Etherpad. Now I did cheat a little bit because now I am right here on the binder hub. I'm going to use from yesterday something that was this, because this is way too long. Okay. Not found. All right, dash help then. There you go. So thank you for that one. I did actually miss that one. It should be Conda dash help. And now Conda will show all the options that you have. Clean is something that I did not mention, but for those of you that are actually working in our clusters, please use clean on the regular, because there are so many people that is like, wait, I run out of quota. How? Why have so many files and I cannot see them? It's because probably Conda is actually hiding. It's actually hiding all the things that is installing from you, and you cannot directly just erase them. You have to do cache clean or clean. Okay. So I am at home, and so far so good. I'm still in this place, which I was told that yesterday you do not have this one, but I do. So as I said before, you look to a Jupyter lab like this. Should look somewhere like this, right? You have your files here. You have then your notebook option, your console option, and then other. And this is the terminal. If you click here, it opens another terminal for you. If you are bothered by this long thing here, you have it here on your in your Etherpad, how to just make it super small, and then your prompt is a $sign. Or if you want to play around, you can also do something like this. And now it's something like an arrow. Okay? If this is bothering you, there are other ways to actually modify the prompt look like. That's very advanced, and we're going to stick to just the $sign. So to hide your things, you can click here in the file browser and it opens up. So is this a good font to have? Can everybody see this font? Pretty much all the way to the back. Can you see it? All the way to the back. Can you see it? Okay. Nice. So like I said, last time we were actually using something like color equals auto. And I have only, let's clear this. I have only here the share lesson data from last time, because the ClassHub still remembers what I did last time. But what we're going to do is just check out now something I just said. We're going to start by looking at the list of Conda environments we have available. All right. So for that one, Conda emp list. If you write this, it will tell you like there are in the ClassHub 2 environments, as a matter of fact, the base and the notebook. Those that are working on their computer, you should have only see base, maybe. Okay. So you always start Conda with, once you install it, you start here with the base environment. Rule number 1, do not touch the base environment. Whatever you're going to install it in a new environment. Okay? Base, never touch it. Please. Why? Because I remember one of my colleagues, he was just installing library after library on the base environment. That's not the idea. Base environment is the root, and it should be like the master part of all your other environments. Okay? So avoid trying to install things on base. Okay. Now, the question arises, how do I create a new one? Correct? Very simple. But let's ask our friend Conda. That just help. And search for it. Where are you? Clean, compare, config, create. Here it is. Okay? So if you write Conda create, and then I hope that does help, it will deploy all the help options, meaning that it's not only that. It's like you can use create and then all these options over here. just to try to create something new. The basic one, as a matter of fact, is just conda create and -n and the name of the environment. Like, for example, conda create -n. You have this one here, my emp light. Well, we can say new emp. And if we just hit enter here, it will create something new, a new placeholder. Meaning it's going to create the placeholder for the new virtual environment. It will take a time, apparently. And if you do not want to wait, let's go conda deactivate. Yeah, no, I should actually try to do this. There you go. So the reason why it got stuck is because it takes a lot of time to actually just do a placeholder for some reason. There you go. Finally. So it also tells you, like, if you want to use that new environment, you can use this. And when you are done working with that environment, use this. So again, if we do conda emp list to check out our list of environments, I have my new environment here, and I have notebook and base. So, for example, if I want to navigate between one of those, conda activate my emp, and you can see that now it's telling me my emp is active. Okay. If I go and try to go to notebook, it tells me now you're in notebook. Super quick and super easy if you pretty much know how to solve these things. And when you're done, you can copy deactivate, conda deactivate, and you're supposed to be back at base. Now, whenever you are doing conda emp list, you will see an asterisk. That asterisk is telling you where are you, so you don't get lost usually. Also, you saw, like, if I am inside of one of the conda environments, I can just jump to another environment and they are isolated. Now, let's do some other tests. For example, let's start with conda emp and Python equals 3.7 point asterisk, whatever Python 3.7 you want to give me. And I press enter. It's telling me that that already exists. You're totally correct. Let's change the name to Py7. Py37. Okay. I'm telling yes. It's installing 3.7. There it goes, there it goes. Okay. And it's telling me the advance. So this visual display is basically for you not to get bored. It's done, perfect. And I will do 3.9 here as well. Let's do this. Ta, 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 ta. And it's working efficiently, apparently. Okay. Once this is done, there you go. I can do conda emp list. I can see my Python 3.7 and my Python 3.9. Conda activate to go inside of this guy. Okay. Python dash version is 3.7. And then conda activate 3.9. And we do the same. You see? One is working with one version and one is working with the other version. That's as simple as that. So right now, what I want you to do is actually create, I don't know, 2 or 3 different environments, maybe with different things. You can do Python different versions, or you can do SQLite. The other one can have SciPy or R, stuff like that. Right, just to work around it. Create uh, 2 or 3 different environments. Yes. Ah, okay. I can put it over here. Conda. Ah, not this one, right? Okay. So create Conda, create. Then you give a name, my name, and then space Python equals. If you leave it like this, it's going to install whatever. 3 point asterisk is going to go for the last version. And if you want to be a little bit more specific, like I did, it was this one. I will put pi 3.8, something like this. I will copy that into the ether path. Okay. So, okay, just tell me when you're done creating at least uh, two different environments. Okay, raise your hand if you already done it. Okay. Loading, still loading. Oh, don't worry, we will put this on the Etherpad so you can replicate all of this. By the way, the other one that I should put. Not there. That's all. Mm-hmm. So what's the difference between Conda deactivate and Conda activate? Oh, okay. So what's the difference between activate and create? Uh-huh. Uh-huh. Ah, all right, all right, all right. The syntax. So what happened here is like I wanted to create something that was an empty environment. Okay. If I write this just like that, Conda should create an empty environment, basically an empty placeholder. For some reason, it takes a while, but then what happened is actually a good question to follow up. So I have now different environments here, right? I have an empty one. I have my environment, which I do not know what it has. And then I have Python, something that has installed Python 3.7 and something that has installed Python 3.9. So the empty one, I can install whatever I want inside of it. just as a test, or I can just literally get rid of it. So the question begins as, what do I have inside of that thing? So for example, to know what's inside of your environment, because now we have 5 and I do not know what each have, Conda list minus n, and then we can go for empty, and it's telling me you have absolutely nothing inside. Okay, now let's clear this because it's already very cluttered. Conda emp list. Now, if any of you can be a lamp and tell me what's the other option that we can use to see the exact same thing, there is another option. But if you can put it on the Etherpad, that would be sweet. But for this one, let's stick to this one. Conda environment list, I think is pretty straightforward. And then if you use Conda list, it will tell you what's inside of it. So if I go and it's like, okay, what is in my environment? It has nothing. It's also empty. If I do Py39, then there is something. Of course, there is Python here. If I am just interested in that, I can pipe it and say grep Python. And then I can just have, let's clear this. Okay, I can just have the version I am actually running in this environment. You might have noticed already something over here. So there are columns when you do list. The name of the package, in this case Python, the version of the package, and something that is called build. Now, this is where things actually get complicated, because software developers build one of the softwares for Linux. Some other develop for Mac, and some other develop for Windows. This is the thing that changed between the different systems. These two, Python 3.9.20, that doesn't change across all of them. This is the thing that you have to be wary about, and it will be something that you have to check. And lastly, but not least, is the channel. The channel here is called Conda Forge. What is a channel? Basically, it's like a library of libraries. So some corporations, some enterprises, private institutions have their own channels where they maintain the software. For example, NVIDIA has its own channel for their own stack of different libraries. So if you want to access that one, you have to tell the Conda manager, I want to go to the NVIDIA channel and get that. Okay, that's later. But so far, everybody has 2 or 3 Condas environments. Maybe one empty, maybe not. Yes? Everybody fine? All right. Yes. Okay. Yes, that's a very usual problem here. We have connection issues. Okay, now that you created a virtual environment, it's time to destroy it. How do I remove stuff? So usually your logic will tell you like, okay, let's go conda dash help. And there is something called remove. And you will think at that moment, oh, it should be that easy, like conda remove minus name empty. And in theory, because you think this will work, you hit enter. And then it doesn't work. And it's like, what am I missing here, right? So it turns out remove also needs an extra parameter. Why? Because it can allow you to remove just specific things. And if you want to remove everything, you have to do dash dash all. It can actually allow you just to say, like, from this environment, erase one thing. In that moment is when everybody screams like, why is this so complicated? Because it is complicated. If you do empty dash dash all and then minus y, I cannot remove current environment. Okay. Yes. Forgot to put minus n. Okay, like this. Remove all packages from here, empty, and because it was empty, empty was just destroyed. So Conda emp list, and I don't have empty anymore. Okay. Now, what I was telling you, if you're not going to do dash dash all dash dash y to remove everything, put this over here, by the way. Remove all the environment. So if you want to, for example, remove from Pi 39 just Python, it will go through the list and try to check if there is something called Python inside of it, and then just remove that. It will not remove the whole thing. It will take its time, apparently. Works in mysterious ways. Go on, keep thinking. Okay, in the meantime, please can you all remove something completely? Do dash dash all dash y. It should remove whatever you choose. In this case, we're using the name of the environment. Okay. Wow, it's taking so long to find one package. Yes, if you want to remove a Conda environment, you cannot be inside of it because it's like auto destruction is not allowed in Conda. So you have to be outside, actually. In this case, we are in the base, and we can destroy all of this. I will destroy this one, for example. Conda, remove. The name is myemp dash dash all minus y. And it's completely removed because there was nothing in there. I can remove also pi 37, and it's just getting everything done. And for each time, I get one less and one less and one less. Okie dokie. Okay, people, so break time. 10 minutes break, all right? So you can refresh, you can check where you are actually getting the most questions, and of course we can discuss it on the break. But if not, go ahead and get yourself some cookies. All right. Okay. Testing. All right. Can you hear me correctly? Good. Ugh. Okay. Some unforeseen things is like some people that is using MacBooks have to switch from ZSH to just Bash, which is what we're using here. And that's becoming a problem because apparently locally you cannot work exactly comfortably. Okay, let me change this to that. Okay, clear. All right. So what I was telling you before the break was to create an environment and then just to remove it with dash just remove all. And now somebody was telling me like, what happens if I do not have a name for it? Like, let's say I create, let's go over create, easier. Create -n and then nothing, and then let's say Python, and then equals 3.5, whatever. So it will take its time because it will be trying to solve stuff. And in the meantime, you can open another terminal, do the same export, ps1 equals like this. Conda, deactivate, and I should be back at base. Okay. So we're going to create this, and now Conda emp list. I have something very weirdly named here now with a wildcard and everything. Instead of installing Python, I just name this thing Python /.* and so on and so forth. There is another way to actually remove things, and that's using the path. As you see here, you have the name of your environment here, but you also have the path over here. So you can use that one to remove everything. You can either try remove -r the whole thing and it will work, but you can do the elegant thing and do Conda remove -p and then the path -all -y. Okay, and this one will remove also the environment you created. Okay, we will move to a new exercise where you will try to create environments in different folders. All right. So the first thing is like we should create new folders. I'm going to create folders based on right now my favorite actors, nkdir -p, Ryan Reynolds, and Hugh Jackman. Maximum effort. So I can create these 4. Okay. Those are our new folders. Now, what if I want to create something inside of that folder? So let me tell you the following. In theory, for data science and to work like across different teams, the good practice would be like inside of a folder, you put the environment you're going to work. All right. So in that case, you can do Conda create -p. Let's start with Ryan and do /emp. Now, as a good practice, what people does is to create inside of a folder something called emp, EMV. So that EMV is the actual environment that you are going to share with somebody else. You can actually compress this env and send it forward to somewhere. Okay. So in this case, let's try with Python equals 3.5 dot asset. All right. And then, yes, like this. It will start. Meanwhile, in another terminal, there's still no creation, clear. I have to go inside this thing. Here it is. Now I have Ryan Reynolds and Hugh Jackman, and I can do Conda create minus P Reynolds EMB, and I will put SQ light. There you go. And yes. And here in terminal 1, still is trying to find it. Okay, meanwhile, this is running, this is running. Try it for yourself. Okay, you create 4 different folders, whatever the name you want to put it, and then try to create, what is it, by the way? It went away. Here it is. Try to create an environment using the -p option, creating each of the folders an env folder like this. There you go. Accept, and then do Conda and list, and you should have that environment just with the path, no name. Okay. Just like this. Conda create -p, the name, and then /env. And then whatever you want to do, you can install Python, you can install SQLite, whatever you think is faster. You can even install again Python 3.9 or 3.8. Like, let's do it with Hue. EMB, and then Python equals 3.7. Okay, because we already installed it, this is cache in the memory, so it's going actually faster. Now it's working, they're executing. Okay, how about you guys? Are you going over this? Were you able to delete the environment with no names? Not. All right. Yeah. Can we give this environment a name? I always get this question. And they conflict. Yeah, if you either use -p or you use -n, because the manager is telling you, like, okay, so what you want to do? You want to create an environment in the place you're telling me to create it, or you want to create an environment in the default place where I will create it, and we can put a name. Now, for those environments that you are giving the -p, which is the path to the folder, you certainly can rename it. That's on the documentation. And I usually don't do it because I rather to have them in the path. And I always activate them using the path. Because I'm 100% sure that I'm not activating another thing. So in this case, for example, it stopped installing Python, what was it? Python 3.7 in HueEnv. As you can see here, now only Jackman is basically with nothing. Ryan Reynolds has something inside, aside from the jokes. And then Hugh has something also inside. So if we do Hugh, you will see here's the emp. So if for some reason I need to send this file to somebody else in another country, in another, not even in another country, in another faculty, I could tar this file, this folder, and send that over there. Okay, that's part of the idea. As long as the other person is also using Bash and pretty much the same kind of environment. Let's say the hardware environment. So if I do conda emp list, now I have 3 paths here, which is telling me at your home, at your user, inside of this folder, you have an environment here, an environment here, and an environment here. And the 3 of them can be different. So if you, again, want to see what's inside of each, you can do conda list, but instead of -n, -p, and the path. And this should give you this. All right? So you have your name, your version, your build, your channel. All of them come from Conda Forge. If you already notice, that's the default. Take Conda Forge as the Wikipedia for libraries. Something happened? Okay. So let's clear this. Conda emp list. So what can I do? I can remove all of them. I can remove, for example, this one, because why not? Conda remove -n. This guy. As a matter of fact, let's use -p. And then dash all dash y. This will remove everything without asking me if I want it or not. And then I just have these guys. I have Hugh, I have Reynolds, and have Ryan. And the 3 of them can be completely different. And I can keep checking each of them all the time. Okay, now we're going to add one more thing. Like I told you before, there is some things like, for example, this library. NVIDIA. There you go. So, for example, in your journey, you will try to do data science now in GPUs. If you go to install, it will give you this kind of setup, which is very nice, where you can select the method of installation that you want. One is Conda. And if you go here, you can copy this command. But as you can see, there is something right there that I want to check it out with you. So if you see here, there is the name of the environment, but then there is a C, and another C, and another C. This is the way you actually tell Conda, use the channel or go to this library over here. In this command, it's going to create an environment called Rapids. But first, it's going to check the library from NVIDIA called Rapids AI. Then it's going to check Conda Forge, which is the Wikipedia that I was just telling you. And lastly, it will go to the NVIDIA library of libraries. and then it will fetch each of these things that you have here and try to install those one. For example, I know that this will fail in this setting because what we have in the class hub is actually just CPUs. This one will require GPUs. But if you have, for example, any library that you want to check, you can always go and say like, okay, Conda install, and let's say Dask. And it can be the first or the second, apparently, choice. You click here where it says Anaconda, and it will tell you how to install it. Now, you see here, there has been a change of notation. But these 2 points that are connecting each other is basically the same stuff. What I mean is you can use this one, or you can use, let's get this out of the way, clear. Something odd happened. Okay. One more time. Something. All right. So this Conda install Conda Forge Dask is basically telling Conda, hey, look in Conda Forge library for this package called Dask. The same thing can be achieved by Conda install -c Conda Forge Dask. These 2 lines are exactly the same. They are telling Conda the same thing. So this notation on the top is very useful if you're going for one package or for 2 packages that you know that they're in Conda Forge. But if you're going to install a series of packages, then you're going to try to resort to something like what NVIDIA does, like this one. Because here you're trying to actually search through different libraries to fetch the programs that you want. So this notation for me is more clear using the -c. And it also gives priority. Conda has a hierarchy. Whatever you put first, in this case Rapids AI, Conda will go first to search in that one. If I put Conda Forge, then it will be first looking in Conda Forge. So the order here matters. I'm telling you this because sometimes people have, for example, like this one, Conda install. Yeah. So there used to be a moment in time where this one has their own channel here, like called BioPython. So you have to call this package from BioPython. And sometimes it was very confusing. Anyway, okay, let's go back to creation. So far, here, this is pretty much too much. Test, okay, that's okay. Conda and please. And so I just want to complete the four folders that I actually created. I just still have Jackman. What I can do now is to create Conda create -p Jackman /env, and then I can use -c Conda Forge, and then I could do Dask, maybe something more like NumPy, SciPy, and Pandas. Okay. These 3, I think, are the best friends of a data scientist. They are the usual workhorses. And let's see if -y works. So it will take a while, but now I can create. In the meantime, let's Conda and list. Okay. Let's Conda remove -p. Let's call it like this. Let's get rid of Reynolds. Dash dash all -y. Okay. Everything should trigger something. Everything will take their time. So one thing that you probably have checked if you are done this several times is like Conda goes pretty fast when you call for things that you already search. That's because there is a cache in the memory. So it's getting the packages already there, installing it in your virtual environment. Okay. Done. Excellent. On the emp list. Now that I get rid of Reynolds, the problem arises like, why did I do that if I was going to work with it again? Meaning like, what can I do to preserve what I already installed if I went and installed several libraries and it was all in Reynolds and for some reason I destroy it because I don't know, I wanted to clean stuff and I mistakenly just deleted that one. So now I'm going to tell you how to export in a fashion, in a better way, the Conda. Because literally, you could go inside of CD Ryan. Now that we are inside of this folder, I could tar this folder, create zip file, and do env.tar.gz, env, and I could send this to somebody who's actually have the same hardware that I have. But if I send this to somebody who is working in Windows, it will not work. Why? Because this was specifically built for Linux. Okay? Is a way of sharing it? Yes. You can preserve it? Yes. As long as you are kind of working in the same environment, it will work. So this is not the best way. Okay. Let's keep it going, keep it going. Okay. So in this case, Conda -- help. Nope. Conda list, Conda package, Conda remove. Not that one. Went all the way up. Okay. So Conda create -p Reynolds and then env ssq light and let's put something like Python equals 3.7 and whatever you want and -y so it doesn't ask me what I want to put inside of it. Finally, okay. So for Jackman, what if I want to actually share this? I could do Conda list -p until this tells me what I have inside. I have all of these packages inside. I have pandas here, Python here, SciPy over here, NumPy over here. It's the latest version for what I see. Okay, so I could go and try to copy paste this and send it to somebody, and it's like, hey, here's the recipe, here is the bills, this is all the information you have or you need, and they will come back with, okay, so how do I install this? Like, you just pass me this file and it's unparsable. I cannot work with it, even though I know exactly what are you asking me to do. So in that case, if we are going to do that, Conda emp help will allow us to do something called export. Okay, given an environment, and export dash help should work also. Is giving us option after option after option. All right. So one of the things that you will find always is like you can use the path or you can use the full name. So in this case, conda emp list. If you do conda emp export, and then you do the path, let's say for Ryan, it's going to create something that you can actually use. Now, this will always be called environment.yml. What I'm doing here is basically exporting this recipe to a file that is called environment.yml, which is the best practice. Like when you want to share your Conda environment, you have to name your file environment.yml. Okay, that's the, let's say, the best practice. This is one way to do it. Okay. Let's take this one part by part. So environment, second ago, there you go. So this one, you can read it here. In the text, you have your Conda channels here. It has name equals null. Why is that? Because I use -p. I use the direction, not the name. So automatically it tells you like, it's a null. I don't know what's the name of this, but it was in a path. Where is that path? All the way down. Prefix. Now you want to take out this line because this prefix is for your machine. If you do it now, it will look something different like mine. It will not be home Jovian. If you're working locally, it will be home your user, and then whatever comes after it. So it's basically the path. So what I advise you to do is actually pipe this into head. It was head and -1. This will not work for the guys that are using Mac and SSH, but this should actually get me back. It will delete that one line because you actually don't want to give that line. It will create problems if you give that one line. In this way, you can now basically eliminate this. Let's remove conda emp list, conda remove -p, this guy, all -y. So you can remove this and you can recreate it once more. And I will teach you how to do that with this environment that we have here. Now that we have also created this guy Reynolds here, clear, I want to show you something really cool. So the thing that we were doing is conda emp export. And then you can use the name like, for example, n base, and it will try to create something out of it. These are the things that are in base. Fine. And now you can see here in the YAML file, it will have a name. But you see all these things. It has actually a double equal sign, right? Equals this, equals that. That, my friends, as a matter of fact, is on the list. This column and this is this column and this column. The version and the build. Best practice, do not share the build. Okay, if I want to share this, what I can do then is dash dash no builds. Okay, and now it's just sending the program and the version. This is the thing you want to share with some other people. Why I'm telling you this? Because it has been quite often that people try to build something on Linux, pass it to their friend that is working on a Mac, and he's like, dude, I cannot create the same environment. What's happening? It's telling me there's an error. The build is that error. Okay? And because of the dash dash no build option, you don't have to go manually to remove all the builds. But that has happened here at KAUST. So even between Linux has happened. Like some versions of Linux have their builds and some other has another build, and you're trying just to recreate the same program with the same version, but the build is causing a problem. Okay, this is how you preserve this thing. That's fine. Clear. Now, if you do that, no builds, and then you do head minus n minus 1, and then let's call it environment. Let's call it, what was it? Base. Just to make it different from the others. Okay. So that one can recreate base, but you see, it's a different kind of stuff when you have a clear idea of, okay, you're using this program and this version, rather than the whole thing that then becomes cryptic with the build. Okay, so in this case, we have environment here, and I actually deleted Ryan. And what is Ryan without Reynolds? So maximum effort. How can we use now the YAML file? Conda m create. Okay, this is the special one. It's not just create. Minus file. And then here, environment. And now you give the path. Now I want Ryan m. Okay, this should work in theory, but remember, this is live coding, so it can go sideways. But this is the way you can now create your YAML file. It will start to build again Ryan/emp. Okay. Meanwhile, Conda emp list. It will not appear here yet. But if I want to save each of one of these, I can do it. I can save Hugh Jackman. Yes. Which one? It's not there. Yes. It's being created. Yeah. It will not appear until it's done. But you see, it's thinking. It's going well, but it's going. So what I want you to do now is I want you to create 4 folders, whatever you want to name them. Create in each of them an environment. Okay? Let's put this even easier. Create 2 folders. In each folder, create an environment, a different one. Like in one, you put Python, and the other one you put SQL. And then I want you to save the environment YAML file. Okay, with Conda export. You see, it's going. Ryan is being created. So I will put that, as a matter of fact, all the way here. So if you're in the other path, you can check it out. And then I create it again. So come on. So in this case, I'm going to save Hugh Jackman with minus P. Then let's save Jackman. Okay. Success. I recreated Ryan. So I have Ryan Reynolds there again. A different Reynolds and Ryan. And it's not different from what I have. I just recreated using the environment YAML file. Okay. As a matter of fact, you will see over this over here that this is environment Hugh and this is environment Jackman. Both of them are different in the sense that I installed Python 3.7 and 3.12 in another one. So I can actually now remove Hugh Jackman from my environments and I can then recreate them using this. So that's the trick. And if I want you to have Hugh Jackman, I can send both YAML files to you and you will recreate the same environment I have. Even though you probably are working on Mac or in Windows, you will have the same Python and the same version. The build, however, will change. Okay? All right, how far are we? Did you create 2 folders, 2 environments on each? Not yet? Okay, run over there. So how about the rest? Everybody is following or do you have any problems? Okay, you're trying. That's a good thing. You can work on IBEX in theory. And I have a question for your computer because it's really, really, really strange. Let me check the chat. Okay. TSH. Okay, let's close these two. Get this one back. There you go. Okay, raise your hand if you're trying or you're stuck. You're trying. Okay, trying. Good, good. The last code. Hmm? The last command. You mean this one? The conda m create? Aha. Yeah, this one, right? In the etherpad. Yeah, this one is to create a conda file. No, sorry, this one is to create a conda environment using the YAML file in the path that you want. Okay, even if you erase, for example, Ryan/env, this command will create the folder Ryan and the folder env. Conda will read the environment and then it will create it. Okay, that's the whole explanation. Now, if you notice, is just there is one twitch which is env. It's not directly conda create. In this case, that's the only difference between conda create and then your path. This is conda environment create, use this file, and then in this path. You can change the path also for name, but it doesn't quite work smoothly. Okay, so there is that. Yes. Here it is. Yes. SQLite. SQLite. Yes. Yes. Over there. How long do we have to clean the cache? Okay. Here is a. I should say like how often should you clean your caches? How often you should take a shower? But here is the catch. How many installations are you doing? In my case, I have like 10 working in Conda environment. No, let's say less is less. I'm just lying to you in that sense. If you see here, let's blow this up. So clear this. Conda emp list. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. I have around 15 different environments. So I'm installing different libraries on each of them. By the time I reach 5, I clean. Why? Because you can start trying to, for example, install PyTorch, and yet that's a very beefy one. After that one, you probably want to clean your cache. But if you're trying different version of PyTorch, stay with the cache part, and then after you find the sweet spot, then you clean. Because the cache, it's a very bad that you don't know how to clean the cache, because it will put a lot of files that you cannot see clearly and erase. So it depends, but for example, in my case, after the 5th installation with Conda, it's like, okay, I better clear stuff, because if not, it's getting my bytes away. That's good, yeah. Especially if you're installing deep learning libraries, yes. after each installation, if you clean, that's totally fine. If you're trying different libraries until you find which one is the best one, you're building too much, then probably the cache is a good way until you find the sweet spot. But yeah, if you have an environment YAML that right off the gate it will install, clean the cache after. Okay, I will show you something else, and then we go into a break because I see you decaffeinated already. Okay, so Conda M export has actually a module called let's use Ryan again, called from history. So from history, learn to type. You see, the best thing you can do is learn to type. So from history will give you pretty much a summary also, just like no builds. No builds. Ah, it didn't work like that. Okay. Word dash help. And from history, here it is. So the thing is, like, from history can actually give you a smaller YAML file, which is a little bit more generic. Because if you saw your YAML file right now, it's actually pretty large. So all of these guys are here, even with the build. And the only thing that you did was actually asking just to install this, right? So sometimes when you have different YAML files that you want to, let's say this is base, we can go over it again. Like Conda export -p, this one dash from history. Yeah, there it is. All what you did was doing this. Okay, so the from history has one drawback. From history will give you just a quick glance at what you did, exactly what you did. We were just telling like Conda install Python 3, and then all the other libraries are fodder. Well, not fodder, but I mean there are a lot of information that you probably don't need to recreate your program. If you're installing 2, 3, 4, 5 different libraries, just telling Conda install these 5 ones is enough to make everybody just to recreate your environment. So from history, just make it pretty easy, pretty straightforward and short. The problem of from history is that it used not to put all the channels. So if you were actually installing things from another channels, from history will not take it into account. So beware of that, because no builds, export dash no builds, actually lists all the channels that you were using. And from history it doesn't, for some reason that I don't understand. And even people has told this to the Conda maintainers, and they just decided to leave it like that. But you can combine it in a text editor at the end of the day, just like all the channels that you were using and all your dependencies that you needed. Okay? And this can be also saved as get -1 -1 2 as a YAML file. Like this is you. Let's put it from history. Okay. So you can save it like that. You can edit it alongside with the no builds. And then you will have a pretty comprehensive and concise recipe for recreating your environment. Okay, guys, let's take another break of 10 minutes. And we will be back with just the last part. Because I think we're covering pretty much everything. So, okay. There you go. Okay. Welcome back. Okay. Well, guys, if you made it this far, congratulations, you're still awake. Even better. So, one thing that I want to tell you, for those that are using the KBL binder, sorry, your memory is very low. I know you have to struggle with that one, but okay, that's the emergency thingy. If you get into ClassCop, you will have more memory. Now, something that is kind of related to how we work here at KAUST, especially in the supercomputing lab. We advise people to actually use Mamba. What is Mamba? It's basically the same thing as Conda, but it's slightly, or I should say, most of the time, it's faster to install things with Mamba. You don't have to actually learn a lot of Mamba because it's an in-place replacement, meaning that all the commands that we saw now, except for activate and deactivate, are the same. So I have Mamba here and also help. So if you go to Mamba, it's basically the same stuff. Compare, config, create, because in theory, what this does is going and use parallel installation, meaning that it will use your CPUs, each of them, to install a different package or a different library. But it's basically the same. If you do Mamba create -n my amp and then Python equals 3.9, it will start like that. It will have some, some visual aid. It's like, I'm looking for this thing. I'm looking in different packages, especially in Conda, and then you have this. Like, I will install these packages. Then here, I will try to do the same. And all of the commands that we were doing now, suffering through, is the same, except this thing. Because if you try to do this, oh, wait, it worked for some reason. Maybe the new can do it. But anyway, if I do Mamba list -n my amp, deploys exactly the same stuff. Even export is the same. Okay, this one is just faster. That's the point. If you have to install a lot of things, you better use Mamba. Like Mamba, say NumPy, pandas, SciPy. Let's say another one. sklearn. How do you do that? Well, Dask. Dask and scikit-learn. Yes. Scikit-learn. Let's go for on the install. And here you have it. Okay. Yeah. Okay, in this case, scikit-learn. Let's call the channels. I want you to go first to Conda Forge and then the channel Anaconda. I do not understand why there's still a channel Anaconda, because theoretically, Conda Forge is more up to date always than Anaconda, but some way, somehow, this still exists. Up. Recognize arguments. Where? Okay, maybe yes. Nope. Nope. Okay, then let's put them over all the way here. Then this here. He doesn't like Anaconda for some reason. Okay. Let's do that. I'm doing something really wrong. Really, really wrong. Of course, I'm trying to get a list. So instead of doing that, I have to create something. Yep. Live coding, everybody. Always something like this happens. There you go. Now it's telling you I'm looking for these things. Give me a second. Then he went and searched first for Conda Forge, then for Anaconda. Again, the channel Anaconda, take it with a grain of salt. Basically the same thing as Conda Forge, but Conda Forge is more up to date. Sometimes they just point you to this one for some reason. Okay, so it will start working at some point. In this context, yes, but if this were another library like the NVIDIA libraries, it will have also like no arc, no architecture, and also like we're working on Linux 64 bits, so it will try to check for those. These are things for the developers that is like, are we pointing to the right direction? Or are we going to go and search for another thing? Now I'm getting all of these. I say yes, and then it starts installing. You see, it's pretty fast. If you want, let's try it. Why don't you create your first environment with Mamba? Just do the same. Mamba create something, and then you can install stuff like I did. Like for example, this one command, I can put it over here. Let's put it over here. Okay. And you see, I have now 2 new environments. I still have Hugh Jackman and Reynolds Ryan. And I can work with them the same way with Mamba. The only trick with Mamba is that it runs faster. So you can test it, you can try it. The time that you spend installing things, heavier things, it will be less considerably with Mamba. Okay? Yeah. Yes. Yeah. Okay. All right. So the difference between what's going on with all these snakes and all these names, right? So the guys that were developing this, they were Python developers. This is why they put Anaconda as the name. So if you install Anaconda, you are installing a big, very big chunk of different libraries. It's basically bringing all the kitchen and sink to your computer. Even with the Anaconda Navigator, you will have everything inside there. Okay, it will actually, in theory, should work right out the gate. It doesn't have to fetch anything from internet, in theory. Then, because this was very big, meaning some gigabytes of memory, it's like, well, we don't want to do this. Why? Because technology is migrating to faster, linear, and smaller. Therefore, they needed something actually less complicated for people to install, and they created Conda. And Conda is basically the name for all this installation that we did here. But Conda had the problem that it's a serial installation process. So if you give 100 packages, it will go one by one by one by one. That was the original Conda. Now is multiprocessing, but it's still significantly slower. Then people say like, hey, we are migrating to a smaller, linear, faster. This is still too big to just put it inside of a Raspberry Pi or basically a cell phone. Okay, so they did mini Conda. And mini Conda, he is just like the installation software that will call the packages and know where to fetch things. And after that, it was like, hey, you are still doing serial things. It's taking me forever to install 100 packages. So somebody, actually a lot of developers says like, we can use parallel installation. And then they created Mamba. And somebody told them like, hey, we are moving into faster, linear, smaller. And they created something that is smaller-ish, and it's only megabytes, and it's the installer. Basically, the software, all the software that you need, the bare bones. And this is why it's Micro Mamba. So we here in the supercluster, we advise to use Mamba or Micro Mamba because it takes very few from you in terms of space, and it's all you need to install a lot of things. Also, we are advising to use the -P option to put all your environments where you have the most storage, because this will actually get beefy at some point. It will increase in size. But that's the story. And as a matter of fact, it keeps evolving. At some point, the versions keeps coming. They keep maintaining this. And if you were not aware, Anaconda was in the news a couple of months ago because it was going to charge for some services that we're providing that was free before for all universities. But they were saying that some users were misusing all the technology they were having, or the service they were actually providing. Well, that's another story that you can read in the internet while you're searching for other memes. So that's pretty much it. The only thing that is lacking here is to clean up stuff, not removing. As a matter of fact, it's something that we already mentioned, like how often should I clean cache? So if you remember, clean -help. So this one will remove unused packages and caches. What does that mean? What happens is that you can install a lot of libraries and you install it once, and then Conda store the tar files somewhere that you cannot see forever if you don't remove them. But it doesn't tell you to remove them, neither it tells you where it is being installed. So it's installing hidden folders, and the way to get rid of it is using actual Mamba clean. And my preference is always use, well, Conda clean -all y. Well, clean, not clear. Okay, so as you can see here, very quickly, it removed already about half a giga between all the things that I was just installing now. Okay, so like we were discussing, clean your cache often, depending on how many things are you building an environment. If you're building an environment with different libraries, but pretty much the same backbone, keep it until you find the sweet spot. And once you're done, or if you already did, like I did, 15 different Conda environments, clean after the fifth. Go 1, 2, 3, 4, 5. I have 5. Okay, execute Conda clean -all -y. It will release your space, your physical space, gigabytes, as you can see. At least this is half a giga. But also, let's talk about management, project management. Like, for example, how do you manage your projects? Like, anyone, raise your hand and say, like, how is my project managed? Or do you know what? Okay, raise your hand if you know what's data project management. Seriously, guys? 1, okay. 2, good. Okay, so how is different from normal management, data science management project? What do you think when I say, okay, you have a data science project, manage it? What's the first thing that comes to your mind? Data. Okay, good one. So something like exactly. So KAUST. No. Go into KVL. We actually have to talk about this one over the internet. And is over here. Okay, so for example, we created this kind of project templates. Okay, this is all over the place in the internet. You can find it. This is just one, and we created this one because it was basically our idea. You can have your own idea and do it like you want. But the usual thing that you should have is a folder with the data, and inside of that folder, the different kinds of data that you need. The raw data, that is the most important. Then the processed data that probably you want to publish, and everything else that you can lose. Like this interim data here, just is the things that you can erase, modify constantly. You don't have all your data in the same place, usually, because raw data is very important. It will allow you to remember what happened, and your programs will actually access that raw data, process it, and give you a result. So whatever process happens, whatever intermediate file that you are generating is there, you can delete it because you have the program that will actually work on, right? The raw data. Then, something very often, you have to make a notebook folder for all the Jupyter notebooks that you're going to use, and you will name them 001 introduction until 100 final model. Something that many people need to remember is that they have to list the requirements on the environment YAML file. So people can actually create inside here a folder called env. And this is the way, pretty much in my mind, how one data science project works. At least the data, you should always care about where you put it and how to process it. Because if you modify your raw data, probably you cannot get it back. If it's from an experimental colleague, if it's not a copy, and you have the original one, and you modify it, then probably stops being raw data. Then you have your models, your notebooks, and everything in between that has to jump through the different folders. Okay? So the environment YAML or requirements TXT should be also legible there. You have to be very quick where to put it, and people should find it clearly over there. It's like, okay, this is what I need to create my environment. And that's it. That's pretty much what everything you can do. Hey, in KAUST, where do we save all of this? Okay. Yeah, I mean, it depends. In KAUST, we have different ways to go about it. In KAUST, we have a KAUST GitHub that is private, and you can basically safeguard your things because it's not openly public. Also, your GitHub can be not public, but the GitLab that we have here has more capacity. And then there is that Datawaha. There is some shared resources. Even in the clusters that we have, we use some folders specifically just to share files with some people. And it depends. Usually, if you're attached to a project, you can access the files on that project. But of course, the system administrators have to allow you to go inside of that project. Okay, so there is that. There's many resources. Thank you for asking, because we have many. Fortunately, and still we have them. So you have to ask IT how to access KAUST GitLab. They are the ones that manage KAUST GitLab. Okay, yes. I do not know what's the max capacity now. They changed it recently, so I do not know. But IT, they are the ones managing it. Ask them. For sure, they should know how big can you go. Okay. So far, that's all that I have to tell you guys. So you can create, you can delete, you can export, and you can actually look inside. You know how to look inside. You use the Conda list -p or -n. You can use the Conda m export and share it with your colleagues. You can create anytime, any moment, whatever you have in mind with Conda create or Mamba create. So now it's your turn to make science reproducible. All right. So you're free to go. We are just in track to get lunch. So happy lunch, guys. All right. Right. Well, by the way, if you want, remember there is the Python workshop, and after that there will be more workshops for the machine learning. If you didn't enter ClassHub and you pretend you're going to enter the machine learning one, try to get ClassHub up and running, because that's the tool that we're going to use with Abdul Rafur. All right, so see you in the next one.